Hi there, it's Mrs. Scarple. We're going to continue solving systems with substitution. In your last lesson, you were solving by setting expressions equal to each other. Today we're going to be replacing within an equation. We're going to start with just a basic example of we already know what one of the variables equals, and we're going to replace what that variable equals in the second equation. So here we have y equals negative 3. So we're going to take negative 3 and plug it in for the y in the second equation, because we know that that's what y equals. So we have negative 4x plus 6 times negative 3 equals 30. And now we have an equation to solve for x. We can begin by multiplying 6 times negative 3. So we have negative 4x. Positive 6 times negative 3 is minus 18 equals 30. Now we want to isolate the negative 4x. We want to get the x term all by itself. In order to do that, we need to undo the negative 18. To undo a subtraction, you need to add 18 to both sides. So we have negative 4x. The 18 becomes 0, equals 30 plus 18 is 48. And now we want to get x by itself. So now we divide both sides by negative 4. Because this is negative 4 times x, and to undo that negative 4, you need to divide by negative 4. So the negative 4's cancel, becoming a 1x, equals positive 48 divided by negative 4 is negative 12. And we can check our work. I'm going to use the second equation. We know that y is negative 3, that's given to us, and we're going to check to make sure that x is negative 12. So I do that by replacing x with negative 12 in that second equation. I'm also going to replace y with negative 3 in that second equation and see if I end up with 30. I'm going to check to see to make sure that this works. So negative 4 times negative 12 is positive 48. We already said that positive 6 times negative 3 is negative 18. Will that equal 30? 48 minus 18 is in fact 30, so 30 equals 30 is a true statement. So we did find x correctly, and because what we have is an ordered pair, we have the location of the point where two lines are intersecting. We have x is negative 12 and y is negative 3 in an ordered pair. In our next example, y isn't just equal to a single value. Y is equal to an expression. And we can still substitute. We're just going to take this entire expression and replace the y in the second equation with that expression. So instead of writing the y, I'm going to replace y with a set of parentheses, and I'm going to write the negative x plus 3 inside those parentheses. So that that negative x plus 3 that I show is going to go in for y is going inside the parentheses, and then I finish writing that second equation, plus 5x equals negative 1. The next thing we need to do is distribute. We need to take negative 3 times negative x, 3 times 3. 3 times negative x, that's like saying 3 times negative 1x, is negative 3x. 3 times 3 is 9, plus 5x equals negative 1. This time we have two terms that have x. We have negative 3x and we have plus 5x. We need to combine those terms. So negative 3x plus 5x is a plus 2x. We still have the positive 9 equals negative 1. Now we need to get the x all by itself. And this is where we begin the undo process. I want to get 2x by itself, so I need to undo the positive 9. To undo a positive, you subtract. So we now have 2x, because 9 minus 9 becomes 0, equals negative 1 minus 9 is negative 10. To undo the 2, this is 2 times x, we have to divide by 2. So we have, once we divide by 2, x equals negative 5. Negative divided by positive is negative. We aren't finished, however. We still need to solve for y. So to solve for y, you can choose either equation, but since we already have one equation that's y equals, we can take the equation that's y equals negative x plus 3, and we can take this negative 5, and we can plug it in for the x. So we have y equals negative parentheses negative 5 plus 3. Now a negative subtract 5. That's the same thing as saying negative 1 times negative 5. So a negative times a negative becomes a positive 5 plus 3 is 8. And we should check. Make sure we did this correctly. So if I check with my first equation, does 8 equal a negative 5 plus 3? Well, a negative becomes a positive, and 8 does in fact equal 5 plus 3, so that's true. Let's check it with the next equation. Does 3 times 8, replacing the y with 8, plus 5 times negative 5 equal negative 1? 3 times 8 is 24. 5 times negative 5 is negative 25. Does 24 minus 25 equal negative 1? Yes, it does. That is also true. So we have solved this correctly, and our ordered pair is negative 5, 8. And that's what it looks like when you are taking an expression and substituting it in for a variable in a second equation.